Hi everyone, in this video I'm going to work through a few examples of implicit differentiation. The idea being to work through the three examples we have here, and for each of them we're going to differentiate with respect to x, as well as find dy dx. So let's get started. Example 1, we're given 4x plus 2xy equals to x squared. And so the first thing we need to do, A, is to differentiate this with respect to x. Now, what makes implicit differentiation a little bit tricky is the fact that we need to remember that any y that we come across needs to be treated as a function of x. And for that reason, I often find it convenient to rewrite any expression we're given, like this one here, in such a way that we really highlight that y is a function of x. And one way of doing that is to rewrite it as 4x plus 2x times y of x, which equals to x squared. And although this may not seem like much, rewriting y in this way, I find it impossible to not see that y needs to be treated as a function of x. Now that that's done, I differentiate each of the terms I see here with respect to x. So, differentiating the first term 4x, we get 4, and we add to that the derivative of 2x times y of x. Now, what we're dealing with here is a product of two functions. We therefore have to use the product rule. And you can see the formula for the product rule in the upper right-hand corner of the screen here. And if I treat 2x as u and y of x as v, then this becomes 2 times y of x plus 2x times the derivative of y of x, which would just be dy dx. And that's equal to the derivative of x squared, which is 2x. Finally, noticing that every single term we see here has a common factor of 2, I can divide throughout by 2 and state my answer as 2 plus y plus x times dy dx equals to x. And that's the first question answered. We've just differentiated this with respect to x. We move on to question B, in which we need to find the derivative dy dx. Well, for that, we start from the expression we just found and we rearrange it to make dy dx the subject. So let's see, I need to get rid of this 2 and this y on the left-hand side, and for that I subtract 2 and y from both sides of this expression, which quickly leads us to x times dy dx equals to x minus 2 minus y. Finally, dividing both sides of this expression by x, we find that dy dx is equal to x minus 2 minus y, all of which is written over x. And that's the answer. We've now found dy dx. Let's look at the second example. We have sine of y which equals to 4x. And again, the first thing we have to do is differentiate this with respect to x. Well, just as I did before, I'll start by highlighting the fact that y is a function of x, and for that I'll write this as sine of y of x equals to 4x. Now I can see quite clearly on the left-hand side that I'm dealing with a composite function, so to differentiate it, I'll need to use the chain rule. So let's go ahead. If I go ahead and think of the sine as the outer function, and this y of x as the inner function, then the chain rule tells us that when we differentiate this, the result will be the derivative of the inner function, so that would just be dy dx, times the composite function whose outer function is the derivative of this outer function, so that's the derivative of sine, which is cosine, and whose inner function is the inner function of the original composite function, so that would just be y. And that equals to the derivative of the right-hand side, which will just be 4. And quickly rewriting all of that in one color, that's dy dx times cosine of y, which equals to 4. And that's question A answered. We move on to question B. And again, in this question, we need to find dy dx. Well, the approach is the same. Starting from the expression we just found, we need to rearrange this to make dy dx the subject. Looking at this, we quickly see that all we have to do is divide both sides by cosine of y. And in doing so, we find that dy dx equals to 4 over cosine of y. And that's the answer. Okay, we move on to example 3. And again, the first thing we need to do, question A, is differentiate this with respect to x. Well, once more, I'll go ahead and rewrite any y that I see as y of x. So let's see, that would be 2x squared plus y of x squared, which I'll write in parentheses, that's y of x squared, which equals to 3x times y of x. And now that I've done that, I can see quite clearly on the left-hand side that this y of x squared is a composite function, and I can see that this 3x times y of x is a product of two functions. So for this one, we'll need both the chain rule as well as the product rule. So let's go ahead. Differentiating 2x squared, we get 4x, and we add to that the derivative of y of x squared. Well, just as in the previous example, if we think of y of x as the inner function and the square function as the outer function, then when we differentiate this, we should get the derivative of the inner function, which will just be dy dx, times the composite function made of the derivative of the outer function, whose inner function is just y of x. So that will be 2 times y, and that's equal to the derivative of 3x times y of x, where if I treat 3x as u and y of x as v, that would be the derivative of 3x, which is 3 times y, plus 3x times the derivative of y, which would just be dy dx. And quickly rearranging a bit and writing everything in the same color, I find that's 4x plus 2y times dy dx, which equals to 3y plus 3x times dy dx. And that's question A answered. So we move on to question B. And remember, in question B, we need to find dy dx. And once more, all we have to do for that is rearrange the result we just found and make dy dx the subject. So let's see, I'll start by gathering both of the terms with a dy dx on the left-hand side, and for that I subtract 4x from both sides, as well as subtract 3x times dy dx from both sides. And that leads to 2y times dy dx minus 3x times dy dx, and that equals to 3y minus 4x. And now both terms on the left-hand side have dy dx as a factor, so I place dy dx as a factor to the entire left-hand side. In other words, I write this as dy dx times, in parentheses, 2y minus 3x, and that's equal to 3y minus 4x. Finally, I divide both sides of this by 2y minus 3x, which leads to dy dx equals to 3y minus 4x over 2y minus 3x. And that's the answer. And so that's it for these 3 examples which involve implicit differentiation. And that's it for this tutorial.